Hello everyone, welcome to Mr. Lee's Math Class Videos. I'm Mr. Lee. We're doing 7.5 in Math 1316 or 2412, pre-cal or trig, inverse circular functions. So inverse functions inherently, in order for a function type to have an inverse, it has to be one-to-one. So in order for a function to be one-to-one, for every input value, there's only exactly one output value as a function, and then for every output value, there's exactly one input, is what makes it one-to-one. On a graph, it's the difference between the vertical line test for a function and the horizontal line test to determine if it's a one-to-one function. So qualities of inverse, as a reminder, on a graph, if you have an xy on the original, it takes the x and y values and switches them, so yx will be a value on the inverse. Because the original had to be one-to-one and a function, the inverse also has to be one-to-one in a function. Any function can be one-to-one if you restrict its domain, because they switch x and y values, they switch domains and ranges, and also they switch what they do. Whatever f of x, or the function, does to x to produce y, the inverse function does that to y to produce x. And you can find the inverse by swapping x and y in an equation and then solving for y. So every trigonometric function, though, if you know it will be infinite amount of waves, is going to fail the horizontal line test, which means in order for it to have an inverse, we actually have to restrict the domain. So visually, if we look at sine, obviously it's going to fail the horizontal line test, but if you can cut sine at strategic locations and say look at just a piece of sine, that piece can be one-to-one and still hit all the values sine can take because it just repeats them over and over. So that little piece could pass the horizontal line test, which means you could find the inverse of sine on that restricted domain. So sine generally restricts from negative pi over 2 to pi over 2, because that's where it goes from negative 1 to 1. The trig functions always include the first quadrant in their restricted domain, and it's really about where, and because they're positive in that first quadrant, it's really about where the negative is. For sine, if you look at the first quadrant, just looking at the signs for sine, it goes plus, plus, minus, minus, because it's based on y. So which quadrant next to the first quadrant for sine hits the other values? It's where it hits the negatives. It would be 1 and 4. That's why it goes from negative pi over 2 to pi over 2. And you might want to be like, well, the fourth quadrant's usually from 3 pi over 2 to 2 pi, but the fourth quadrant that's actually connecting to the original first quadrant is the one that goes backwards from 0. So that's why it goes to negative pi over 2. So that means if we restrict sine to the domain of negative pi over 2 to pi over 2, its output range is still the same as normal sine, negative 1 to 1. So our goal is still to hit all of the outputs for the trig functions while not repeating them. So all of the trig functions have a quadrant next to quadrant 1 that has those qualities. Tangent and cotangent actually have both of them, so we'll talk about those as we get there. This is the visualization of the inverse sine. So normally it has angles and it spits out ratios for the triangle. That's what the trig functions do. But the inverse trig functions are going to do the opposite. They're going to take triangle leg ratios and spit out the angles. So it's going to undo the process. Well, which is really important to note. When you see, say, sine of pi, you're really looking at a ratio of values that are on the triangles. But if you see something like sine inverse of 1, this is going to spit out an angle of some kind because it takes a ratio and spits out an angle versus taking an angle and spitting out a ratio. So it's really important to know that distinction. This is the visualization of arcsine or sine inverse. We have two ways for talking about this. In your calculator, it looks like this. It can also be referred to as this. These mean inverse sine. Now, inverse and reciprocal are not the same. If you were like, well, I thought inverse sine was 1 over sine. That's cosecant. It's the reciprocal. It is not the inverse operation. It is the reciprocal. And I know that's really hard because if you saw x to the negative first, that's 1 over x. But sine to the negative first is not 1 over sine. These are not the same. When you see sine to the negative first, the button on your calculator, that is the inverse operation. So it takes all the possible normal outputs of sine and gives you angles. So sine inverse or arc sine, because sine can get anywhere from -1 to 1, normally on the range, it swaps. So it's now its domain, and the range is here. Cosine goes like this. It's positive, negative, negative, positive. So cosine can't use the fourth quadrant because it's also positive. So cosine has to use quadrant 1 and 2, which is from 0 to pi, but its outputs were also -1 to 1, so now it flops. Tangent and cotangent are kind of the tricky ones because they go like this, plus, minus, and they choose different ones. And this is about knowing where the asymptotes when you graphed tangent were. Because tangent is y over x, it's going to go between when x is 0. So tangent will be between in the fourth and first quadrants. One of the differences between this is that the asymptotes occur at -pi/2 and pi/2, so you don't include them, whereas in the range you did include that for the others. Cotangent's similar, but it's in the first and second quadrant because it's x over y. So it's very close to cosine's output. Cosecant will follow sine because it's 1 over sine. The one exception is when sine is 0, right in the middle, cosecant is undefined. So you have two intervals jumping over 0, but otherwise they match. And secant does the same thing for cosine. So this is not like the questions where we ask, find this value or all of the angles that produce this value. So we've kind of done that before, and it usually produced multiple. This is only going to have one specific answer. It's going to be in the first quadrant if it's positive, or it's not going to be in the first quadrant if it's positive. It could be 2 or 4, depending on which trig function you've got. So arc sine of 1/2 is really asking you for the angle in the first quadrant, since it's positive, where sine is 1/2. And sine is 1/2 at 30 degrees. We're generally going to use radians here and not degrees, so the 30-degree angle is pi/6. Arc cotangent of -1, it's asking you what angle, where cotangent is -1, is kind of in that range. Cotangent as in the first or second quadrant, so if it's negative, it's the second quadrant. The second quadrant angle that has a cotangent of 1 is the 135 degrees, or like the 45-degree reference angle, or pi/4. So this should be 3 pi/4, because it's in the second quadrant. Now arctangent of -1 actually is in the fourth quadrant, which isn't possible for cotangent. Secant inverse of √3/2. They're going to start trying to trick you. Remember, and this is about the domain, secant is always greater than 1 or less than -1, which means whatever's inside here has to be, it can't be between -1 and 1. Now √3/2, if you look as a decimal, is a little bit about 0.85-ish. The point is, that's between -1 and 1. It doesn't work there. So tangent and cotangent, it can happen with anything on the inside, can produce an outcome. But sine and cosine, the inside has to be between -1 and 1, inclusive, but for secant and cosecant, it actually has to be outside -1 and 1, of which 0.81 is not. So this is not possible. There's no angle, because there's no angle where secant is √3/2. Cosine does, but secant isn't. But we'll continue practicing these things in the next video.